Hello everyone. So now if we see we have the GRE and IPsec tunneling. So we are going to check first GRE and then we are going to apply the IPsec on the GRE. Then separately we are going to look what is IPsec and all detail. So first of all GRE. We need to remember GRE is nothing but generic routing encapsulation, the full form of the GRE. It is a tunneling protocol developed by the Cisco and that can be used to encapsulate wide range of packets. We are putting packets within a packet. We are putting packets within a packet by using GRE. So what we can say, GRE is a mechanism that can encapsulate one protocol in another protocol. And we are going to see that one. It is a tunneling protocol. We are going to create a tunnel between two branches by using the GRE. So what we can say, tunneling is a concept where we put packet into packet. So inside packet we have packet inside another packet. So that's one we are calling as a GRE. That is nothing but putting one packet inside another packet is nothing but encapsulation. So what we are going to do, we are going to create the tunnel between the two branches. But here we need to remember GRE is not encrypted. He is not going to encrypt the packets. So whatever packets we are sending through GRE, it is in the clear text. If anyone is trying to capture our packets, they can see that one. So what we can say, GRE is a tunneling protocol which is developed by Cisco, and what we can say, in this one we are encapsulating packet within the packet and it is sending by using the tunnel. We can say GRE is a VPN. GRE is a VPN we can create between two branches. The drawback here is it is not encrypted. He is not going to encrypt any packet. So it is in the clear text. If we capture by using the Wireshark or any other tool, we can see what is happening inside that packet. So then why we are using the GRE? There is one advantage if we use GRE, because GRE is going to allow multicast address. When we are configuring the GRE, it is going to allow the multicast IP to travel from source to destination. So what are the advantage if we are having this feature? If we are allowing the multicast IP, what advantage we will get? We can run the dynamic routing protocol. Example, imagine if you see here, I have here one branch. Imagine this is my head office. This side I have head office. This side I have internet. This side I have branch office. So what I will do, here I have, this is my IP. Here I have some LAN interface IP. Same thing in head office we have LAN interface IP. We have the public IP. If I run dynamic routing protocol here, I can share this route here and I can share this route here. I can share other way also. I can do static route also to do that one. But the drawback with static route is if this network will go down, it will not affect in the system until we configure the new route. But if we configure the dynamic routing protocol, automatically router is going to look the alternate route. So that is the advantage of using the dynamic routing protocol. So we can use the dynamic routing protocol if we are configuring the GRE. If we are not using GRE, then we cannot use the dynamic routing protocol. Generally for the security purpose, VPN we are using IPsec VPN. If we want to use the IPsec VPN, we can use, but IPsec VPN separately it is not supporting the multicast address. IPsec VPN is separately, if we configure IPsec VPN, then it is not supporting the multicast address. So it will not allow to send the multicast address. Then we cannot configure the dynamic routing protocol. So what we are doing, if we want to configure the dynamic routing protocol between two branches, we will configure GRE. So with that one we will create tunnel. But here our data will not encrypted, our packets will not encrypt. So what we will do, after first we will enable GRE, then we will do dynamic routing protocol. After that we will put on that one, we will put IPsec. When we put IPsec, that packet will be encrypted, and if anyone capture, they cannot understand what the packet is. So this is a basic theory about the GRE. In interview they will ask they will ask question, GRE is not doing the encryption. So why we are using them? Then what is the use of using them? So we need to tell GRE does not encrypt the packet, but it is very useful because it is allowing to send the multicast address. It is supporting the multicast address. So we can configure the dynamic routing protocol. So what we can do to encrypt the GRE traffic? We can run the IPsec on the GRE. By that one we can secure our traffic. We can say in interview like this way. So let's see what are the steps to configure the GRE. What we can do, we have 5 steps to configure GRE. First step, we need to create the tunnel in the R1 and R2. Example, if you have branch office or head office, we need to create one tunnel here and we need to create one tunnel here. Tunnel name you can give anything. Example, I give one here. Here it is not necessary, both the sides should have one only. Here you have given one, you can give here two, no issue, because this one or two, this is a locally significant. So we will create tunnel. First step, on the both router we are going to create the tunnel. Then after that we need to assign the IP. We need to select the subnet that should be in the same network. Example, I am taking 172.16.1.1/24. So here I am using 1.2/24. So this should be in the same network. So what we done, we created tunnel, both the side. Tunnel number we can use anything, but the IP should be in the same subnet. So this one we done here. After that what we will do, we will configure the source IP and the destination IP in the tunnel. So in the tunnel here we need to configure the source IP and destination IP. So we are going to look how we can configure that one, source IP and destination IP. After that we can run the routing protocol, whatever routing protocol we want to use, static, dynamic, and then we can check. So let's see. First of all, here if you see the scenario, we have ISP here. This is an internet service provider. I taken only one router here. You can imagine hundreds of router here. Hundreds of router will be present here. This is your core of your office, head office core. After that you will have another here. We can see this is a gateway. As we are saying gateway 1, gateway 2. You have gateway here. Then you will have other different like distribution layer, then access layer. You will have so many switches here and raw switches and all VLANs, everything will be here in the real scenario. But for lab purpose, what we are doing, we taken the head office, the gateway directly here, and I created one loopback. I am saying this is my LAN network and this is the public IP. ISP give me this IP, so I assign this IP here, and this is the IP from the ISP side they have here. Same thing, I have one branch here. In the branch I have this LAN network and ISP give me this IP. I create this IP here and I can point the default route towards the ISP. Here also I can create the default route, point all my traffic towards the ISP. So this configuration we need to do. So how we can do that one? Simple, just we will go enable config t host name head office and we can create the IP address. We can check fast Ethernet 0/0 and assign this IP and write no shut, and we will create loopback and write whatever the IP we want to assign. Same configuration we will do for the branch. This one. This is the basic configuration. After that, this is the GRE configuration. So in GRE, what we are saying, first we need to create the tunnel. So I am creating the tunnel in the head office. So this is the head office. How I can create tunnel? Just I need to write interface tunnel and give the tunnel number. And then write IP address and assign the IP, whatever you plan to assign to the tunnel. So this IP I assign. Then after that we are saying define the source and destination. How we will define the source and destination? We write tunnel source, and what is the tunnel source? This is a tunnel source and this is a tunnel destination, the public IP, whatever we get from the ISP. So we will write tunnel source, this is my IP, and tunnel destination, this is a destination IP here, this one. We will define this. Same here also we will do same thing. And after that we will define one default route. I will say IP route towards the ISP here. Same thing I will define all the default route, all traffic whatever I have, I will forward towards the ISP here. I done same thing here. After that what we will do, we need to run any dynamic routing protocol. We can use the EIGRP, RIP or OSPF, anything we can run. I am using router EIGRP1, no auto summary. Network, I need to define which network. This one only. Public IP we will not define anything. In the public IP, we will not do anything. We will define our LAN network and the tunnel what we created. Here also same thing, our LAN network and tunnel whatever we created. After that, what we will do? We will first define that one in the network ID. So this way we can configure the EIGRP as we done before. What we will write? We will write router EIGRP1, no auto summary, network, our LAN network, and whatever the tunnel network. Same thing in the head office also we are going to do that one. After that, just we are going to verify our traffic is going or not, and how it is going, we are going to check that one. And if you see here what we have, this is the ISP configuration. In ISP, what configuration we will do? Just we will assign the IP address to the both the interface. Let's do this one so you will have the idea. Let me show you here. Let me show you. I have here lab. This is the topology we are going to use here. Let me start the router. Okay, why we are doing this one? Example, you have one branch here in head office in Riyadh in one city, and you have another branch that is a branch office in Jeddah. Imagine two different cities, you have branches, you want to connect. Why you want to connect? Because example, you have some server here. This guy from branch office want to access this server. How they can access? Through ISP only, right? Or how you cannot run some separate cable. You need to take lease LAN, virtual lease LAN, but this will be very expensive. If you take the virtual lease LAN, then it will be very expensive. So what you will do? You will use the VPN. You will configure VPN. With that one you can access this server from here. How we will configure VPN? We have different types of VPN. We can use IPsec VPN, or we can configure GRE. So if we use GRE, we can run dynamic routing protocol. If we use IPsec, we cannot run dynamic routing protocol. What are the advantage of dynamic routing protocol? If one route go down, automatically it will look for the other route. Whereas if we use IPsec, we will use the static route, so that static route is not going to check. If one route go down, other route he will not check. We need to do manual configuration. The drawback here, GRE is not encrypted, means all data will be in the clear text. So what we will do, when we configure GRE and when we configure the dynamic routing protocol, on that above we will configure the IPsec. So when we configure IPsec, this data will be secure. So we are going to see that one. So now this is a topology. What I am saying, internet is very cheap. Maybe in $100 we can get the internet, and we can ask the ISP, I need the static IP, not the dynamic IP. If we are getting the dynamic IP, it will change maybe after 10 days or maybe after 8 hours. When we restart our router, it will change. But when we ask the ISP, I need the static IP, permanent IP, they will give you permanent IP. It will not change. They will charge you some extra amount. So we will get the permanent IP along with our internet connection. And after that, we will start configuration of GRE. So what we will do here, we have head office, we have branch office, and this is a ISP. ISP give you this IP for the head office, and for the branch office they give you this 2.2.1 for branch office. This is a public IP you receive from the ISP side. They told you assign this IP here and configure default route towards the ISP, so all your traffic will go to internet. But you want to send to internet, no issue, but you want to send along with the other branch also. You want to make the communication between two branches. So we are going to look that one. So what we will do, let me take the console of the head office and then console of the ISP and then console of the branch office. So I will open the console of 3. Let's see here, let me check. This is ISP console. I already opened the head office. Let me close and open again. Maybe it not open properly. First I will open the head office. Head office is open. Now I will take the branch, the ISP. Generally ISP configuration we will not do. Now in the lab purpose we will do, but in real scenario ISP will do that one. And now I will take the branch office, this one. Okay, configuration is very simple. Just we need to assign the IP address. This is the head office, this is ISP, this is branch office. I already wrote the configuration. I will show you, I will explain you. So if you see here, and let me minimize this one. This is a GRE configuration in GNS3. This is a headquarter configuration. What is the configuration? Enable config t host name interface fast Ethernet 0 by 0, this one, and this is IP 1.1.1 and /8 means 255.0.0.0, and we will write no shut. After that I will create one loopback, that is the interface loopback 0, and I will write IP address, this IP, whatever we are planning to use in our LAN network. So this is just basic configuration to assign the IP. So I will copy this one, I will paste in the head office. So this is my head office, I will paste here. So what I done, just I enable the IP address. After that, same thing here I have for the branch office. So for branch office we can compare here. This is a branch office configuration. Enable config t, we will write host name, then this is the interface fast Ethernet 0 by 0, and here is the IP whatever we get from the ISP 2.2.1 and /8, so I am writing 255.0.0, and then no shut and interface loopback 0. I am assuming this loopback 0 is my LAN interface, so I will write IP address 192.168.2.1 3 times 255.0. So this is a configuration for the branch office. So I will take this branch configuration, I will paste this in the branch office. Okay, so when we paste this in the branch office, now we have the IP addresses. When we assign the IP address, after that if we try to access, it will not work. Example, what I can do here, I can ping also, and let's do the ISP configuration also. This is the ISP, I have this interface, I have this interface, fast Ethernet 0 by 0, fast Ethernet 1 by 0. So if you see here, ISP configuration is simple, just enable config t host name fast Ethernet 0 by 0, this is the IP 192.1.1.2 and 255 one time, and the other interface is 2.2.2 255.0.0. so this is the ISP configuration, just I will put in the ISP router. So I will take this one, let me go to ISP router, this is the ISP router, I will paste here. So this one is good, everything is good, just we assign the IP, and after that this is a GRE. So before doing GRE, let me put the default route. Okay, let me put the default route and try to check we can access our LAN network or not. So what I will do, I will go in the head office and I will create one default route towards the ISP. So what we will do, we will write IP route 0.0.0, and whatever the IP we have the ISP, we will put that one. So this is a default route I am putting towards the ISP. And now I will create one more default route from the branch to the ISP. So I will copy this one, I will go to the branch, I will paste here default route. So if you see, I put the default route here. I put the default route. I am saying 0.0.0, 0.0.0 forward to 2.2.2. If you see this one. So now I created the default route, both having the default route. So both public IP will be reachable. So we can check public IP is reachable or not. So I will write here ping, and what is the public IP? Let me show you here. This is my public IP. This is my public IP 1.1.2, and this is the other public IP 2.2.2. So I will try to ping 2.2.2.2. So this is a public IP, I am reachable here. And if this guy also want to ping my public IP, he can ping. I will write here, because public IP is reachable, we can ping because easily we can access the public IP. So I will write 1.1.1, he can reach to me this site. This is a public IP. This guy from here, he can ping this public IP. I can also ping his public IP. Example, I want to ping this one, I will write here 2.2.1, I can ping. Okay, public IP is reachable, just we will forward our traffic towards the ISP router. ISP know which public IP is where it is, so it is reachable. But if you want to access this one, if you want to access from head office, what you want to access? You want to access 192.168.2.1, then it is not reachable. Why it is not reachable? This is a private IP. Private IP is not reachable. ISP block the private IP. So what we need to do? We need to create the VPN. We need to create the VPN tunnel. So our private IP and public IP, this both private IP can communicate. So how we can do? We can use the GRE. GRE is also tunneling protocol. So we can use that one and we can create one tunnel here. So what we will do? We will create one tunnel. It will become like this. It is directly connected. It will not assume that you have any router in between. It will assume like you are directly connected. This router and this router, both routers are directly connected. even if you have hundreds of router in between from the ISP site, it will show your head office is directly connected with the branch office when we configure the GRE tunnel. So how we will configure? First step, we need to create the tunnel. So what we will do, interface, tunnel interface, we will give number 1. Here also we are going to create the tunnel in the branch office. So how we can create tunnel? We can write tunnel interface. Number you can have here different, no issue. That is local significant. After that we need to assign the IP. We will assign this IP here this side, and we will assign this IP this side. You can use any IP. Okay, I am using this IP. After that we need to define this is a source and this is a destination here. And same thing in this tunnel we need to define this is a destination, this is a source. So we will do that one. I already write here. Let me show you. So tunneling, let me make big. If you see here, this is a GRE configuration. So how we will configure? First we need to create the tunnel. So I will write interface tunnel 1. Then we need to assign the IP to the tunnel. So I am assigning IP address, and whatever the IP we are planning, we are going to write here. Then we need to define the tunnel source. So our IP, if you see, this is our IP. Tunnel source is, so we are source and this guy is destination. So we will write this is our IP, and tunnel destination will be our this IP, this one, our branch public IP. After that what we will do, default route already we created. If you want, we already done this one. Then we need to run the any dynamic routing protocol, so they can exchange this here and this information can come here. So we can use RIP, EIGRP, OSPF, any routing protocol we can use. Even if you want to use a static route, we can use a static route. But in this scenario, I am using the EIGRP, router EIGRP1, no auto summary. Then we need to write network and network ID. Which network ID? Our LAN network and our tunnel, because we are running the EIGRP between our LAN and tunnel. So this one 172.16.1.0, and this will be network ID will be 192.168.1.0. So I will write here this way. This is the GRE configuration. Same thing here, we will write enable config T, then interface tunnel 1, and this is the IP we need to assign to the tunnel, then tunnel source, tunnel destination, and if you don't have the default route, we can create default route towards the ISP. Then we will write the router EIGRP1, no auto summary, network and network ID for this LAN network, and the tunnel IP. So that we need to write, that's all, and we need to paste. So let me copy and paste this. This is for head office. So I will go to our head office here. I can write here, I can paste here. Okay, it is working, no error, nothing, everything is good here in the head office. If you see here, everything is good. So now I can copy for the branch office. So this is for the branch office. So I will copy this whole thing and I will paste in the branch office, and I will paste here. Before, and let me start capturing also here, capturing the traffic here. So we can capture also. Let's see here. When we start capturing here, we are getting EIGRP packets. Okay, because it is we are running the GRE, but what we are getting EIGRP, everything is visible to everyone what is going on here. If we take any packet, if we take, this is our IP, internet protocol, the main protocol which we are using. This is the IP, source is 1.1.1, destination is 2.2.1, and if you see, we are using the GRE, but inside GRE what happening, it is saying here inside GRE it is going EIGRP. So if anyone capture our packet, they can easily observe. What they can observe, they can say this is a IP packet going from 1.1.1 to 2.2.1. If you see, this is a IP packet going from here 1.1.1 to public IP 2.2.1, and what they are using the GRE. Okay, but inside GRE it is visible that we are using what is our this is our tunnel IP, and we are using the multicast with the GRE with the EIGRP, and if we see, this is a EIGRP, all traffic, everything is visible to everyone. So these are the drawback. And now before we cannot ping, now we can ping. If you see here, before request timeout, if you see here request timeout, when we ping this one, so now we can ping, it will work now. that LAN network. Before we are unable to ping, now we can ping. So I will put here. If you see, it is working. Our LAN network is working now. Why? Because we enable the tunneling protocol. We create the VPN between two branches. So now two branches can communicate. Before, if you see here, before when I am trying to communicate, this is my LAN network in the branch office. 192.168.2.1 is my LAN network in branch office. If you see, this is my LAN network. This is not present in the ISP. If you want to check what we have in the ISP, we don't have anything, just we have the IP address. If you want, I will write show run, and if you check what we have in the ISP, we don't have anything. We have only IP address. We have this interface is having IP address, this interface is having IP address. We don't have any routing protocol. Nothing we have here in the ISP router, even though they are communicating. How they are communicating? This branch I learn here, I can ping this one and he can ping me. Before they cannot. How they can? Because of the GRE VPN. Because of that one they can communicate. So now we check, they can communicate, it is working. But here what we observe, whatever traffic is going, it is not encrypted, it is clear. From the IP we can check IP packet, it is showing this is a source. Okay, and if you see here IP, this one, it is showing that one I have the 1.1.1. In that one I have another IP packet, this one, and we are using GRE as well as EIGRP we are using, and we are using GRE. Everything is visible. Anyone can capture, they can take our information. This is not secure, but what we done here, we make the communication between our two branch LAN network. This is our internet service provider. Imagine 100 routers are there here in this place. You did not do anything here. Your company told you want to connect your head office with your branch office. What you will do? You will ask the ISP, give me the static IP. The ISP give you static IP. You will configure here and you will forward your default route towards the ISP. Same thing in this branch, you will ask the ISP, give me the static IP. You will configure here. You will put the default route towards the internet. After that we will do this configuration. This is our LAN network, whatever we have here. Also we will have LAN network. We will create the tunnel and we will assign the IP to the tunnel, and we will create the tunnel source, tunnel destination, both the side, and after that our both LAN network is able to communicate through internet only. We are using internet, but the drawback is our data is unsecure. Anyone can hack our data. Okay, so if you see here, this is only the basic configuration. This is only the configuration for GRE. What we are doing, just we are creating the tunnel and assigning the IP to the tunnel and giving the source of the tunnel, destination of the tunnel. We need to put one default route. We can put here, or already we can put here. No need to put again here. If we put one time, that's all. And after that we can write the routing protocol, whatever the routing protocol we want to run. That's all. And if you want to check, we can check also. This command I can use. Example, let me copy from here only directly. I want to trace how my packets are going. Okay, if I want to send my packet, 192.168.2.1. If I want to go here 2.1 from here, how it is going? Okay, what we will do, we will write trace route and write that IP. It is not showing that it will go here, it will go here, then it will go here. It is saying directly it is going from here to here. What it is showing us, the GRE, when we are trying to trace the route, how my packet is flowing. When I am trying to look how my packet is going, it is showing directly it is going from here to here. It is not considering this one. Even you have 100 router, it will imagine you are directly connected with this configuration. And if you want to ping also, if you want to trace from the branch also, you can trace by using this command from branch office. This is a branch office. We can go here and I can put this one. When I trace, it will give directly it is going to 172.16.1.1, this one. So when I am saying branch office, I want to go to this place, he is saying directly go here. He is not giving anything here. He is not considering this one, imagining that these both are directly connected. Okay, these both are directly connected. An example, if you want to ping, I will write this ping and I am writing source loopback 0. Why I am writing source loopback 0? Let me show you. Here I am standing here. If I ping this IP, it will ping from this side, but I want to ping from my LAN side. So what I will write? I will write ping and this IP. After that I will write source and whatever the loopback. If this is a loopback 0, we will write loopback 0. If this is a loopback 1, we will write loopback 1. So what we are doing, from this side I want to ping, so it will ping from this side. Or if you want to write directly, instead of loopback, you can write source and write that IP 192.168.1.1. So we can ping 1 dot source IP. Let me write here source loopback we can use, or loop IP source. Let me check here what it is showing. Let me make big this one. Source address. So we need to write source address and then IP. Source address, source direct address. So 192.168.1.1. IP does not have the our interface up. Invalid IP. We have two methods to ping: source address. Just give the source address, or we can give the loopback number, so it will ping from that side. So let me see here. This is a loopback one, the one which we use loopback interface. And if we want to ping, we can give the IP here. Let me check here. I will write here ping, and then let me check here. It's giving source IP. There is one command we can ping directly from the IP. It is not taking. Source loopback 0. This will work. Loopback 0 if I am using means same thing, I am pinging from here. But there is one more command. If I want to ping directly from here, I can give source and then I can write the IP address also. IP source address or source IP. There is one command. Source address, and they are giving here. Anyhow, this is the optional command. Directly we can verify with the loopback, but anyhow let me check here. Source address, and other we have only option source address, or we can give the loopback. So this is the loopback here, but this is loopback here in loopback interface. Before we have one command here. If I want to ping, I can write source address, or let me check here 1 minute. Ping example, any IP 192.168.1.1 source IP. So if I am missing anything, it will show me the correct command. Let me check here. Yeah, like this we can write if we want to ping, but here it is not working. Anyhow, this is the optional command. Later I will check, I will tell you which command we can use. But if we want to, what I want to say here, later I will check that one, why that command is not working. The other command which we can use is directly we can write this way. We can write ping and whatever IP we want to ping, then write the source and write the interface, which interface, from which interface you want to ping. So I can say I want to ping from this side. So saying that I am pinging from here one PC, from this side I am pinging. So I am able to ping that one. It is working. Both branches are communicating. Okay, so let me show you here. Both branches are communicating, and the drawback what we are getting here, we are getting that one, our data is not encrypted. So if we want to encrypt, what we can do, we can put the IPsec. IPsec we are going to do in our next video. After finishing GRE, we will do the IPsec in the detail. We need to learn some property, but now I will put the IPsec configuration here in this router, and I will show you This traffic is before it is not encrypted, but now it will encrypted. Generally in the IPsec we will create the two tunnel, one for the control and the another tunnel for the data traffic. One tunnel we will create two tunnel, one tunnel for our control traffic, that is the management traffic, second will be for the data traffic, and we need to apply that tunnel. So now I will explain you this after some time. Now just I will copy this configuration and I will paste. This will be in the head office and the other will be in the branch office. So what I am doing, first I enable the GRE, then I run the dynamic routing protocol, and now I am copying this. This is a IPsec configuration. So IPsec I will apply, so data will be encrypted. So in that one we are using ISACamp, and that is a policy one we are applying. So I am going to explain you that detail. First let's check the output. So when I apply, this is okay, and I will copy the same thing. I will apply for the second router also. I will apply to the branch router also. And after that we will check our data will be encrypted. So now I apply both the side. Now we can check here in this one. If you see here, our data is encrypted here. Before we can see EIGRP, all that one, but now it is not there. If you see before, here we can see what we are doing, ICMP, EIGRP, everything before. But when we done, we have the 6 packet. If you see 1, 2, 3, 4, 5, 6. 6 packet first they will exchange. After that 3 packet they will exchange for the quick mode, and main mode they will exchange 5 packet. Here they will exchange the phase 1 parameter and phase 2 parameter attribute they will exchange. After that they will start. Now you cannot see the other public IP anything, as before it is showing our tunnel IP, EIGRP, everything, but now it will not show anything. Now it will show you only the public IP. This guy is sending some traffic to this and that guy is sending to this. Only you will see that one. All are encrypted here. If you want to check here, if you see what you can see, this is a IP, and in this IP you will see this is a source and this is a destination, and here it is encapsulated. It is encapsulated in ESP. What is ESP? We are going to look now after this one. So now what we can say, all are encrypted. No one can see what is happening, what is going here. Imagine you are sending something in the car or in the truck, and the truck is open truck, everyone can see what is happening. That is the GRE. And after that we apply the IPsec. So we cover that truck. So no one will see what is going inside that truck. Okay. So now you cannot see the traffic. If you select anything, you cannot see. Before you can see what you can see, EIGRP, everything inside you can see here, because that is not encrypted. But now if you see, it is encrypted. Now you cannot see this one. So this is a GRE configuration with the IPsec tunnel. Later we apply the IPsec before we configure GRE. So what is the advantage of GRE? Dynamic routing protocol is going to run, but the problem, when we configure the GRE, data will be not encrypted. So how we will encrypt the data? By applying the IPsec on that one. So IPsec we are going to learn after some time in detail. Now I paste configuration, but I am going to explain you step by step. Like example, with this one we will create the policy, and here we are using the encryption and the hashing technique, and authentication we are defining, defilement what we are using, and the lifetime we are defining. This from here to here will be phase 1, and here we are defining our key, what key we are using, and this is our source destination address, and here the phase 2, this from here to here. Then we are selecting the traffic, applying on the tunnel. So we are going to see this one. First we need to understand what is encryption, what is hash technique, what is authentication. So first we will go for that one. After that we will understand what is the phase 1, phase 2, all that one. So now I will stop this recording. In next recording we will do the remaining explanation about this IPsec tunneling.